Hi guys, I am Vignesh. Now we are going to learn about how to model this tension spring in detail about with Solidworks. First is select a top end and create a new sketch. Simply draw one circular profile at the center point, then give the dimensions of compared to our 2D drawing. I am going to give a 50 mm of diameter. Y means there we have the radius of 25 mm. That's why I given the diameter of 25 50 mm. Afterwards, use an helix curve and select this particular circular profile. Then choose a category called height and pitch. What is the overall height in this current condition for the spring is 175. Here we cannot get the exact portions of this dimensions. Now I just give a dimensional conditions with the 75 mm. Afterwards, what is the pitch distance? It is 15 mm with respect to our 2D drawing in the manufacturing area. Once it is drawn and create an helix curve, now I am going to prefer a front plane and create a new sketch in this current portions. Look at it, what is the exact location we need to draw from this current area means. Choose a 3-point arc. Tangentially we need to connect both the helix curve as well as a vertical construction line. Now I am going to draw one vertical construction line to relate the arc tangentially. Draw one vertical center line from the origin point and choose this vertical line. Just transfer this into a vertical construction line. Afterwards, hold your control button, select both the profiles and make it into a tangential connections. Then select this point as well as a line profile to make it into a coincident connections. Once the profile is drawn, then exit the sketch. Afterwards, we can easily convert a 3D curve by using of this circular 2D sketch as well as this R profile. Hold your control button, select both the profile, go to curves, project curves. In the sketch on sketch type, compared to both the 2D sketch, the 3D curve takes in at the particular locations. Once it is created, now again choose a front plane, draw a new profile. Same as like an R profile, choose the bottom area and draw a 3-point R profile at the right end. First, we need to hide the previous circular profile. Afterwards, make it into a tangential connections for this helix curve. Then draw one vertical center line because we need to make a tangential connections at the right position. Once it is tangentially connected, then either we can straightly give the smart dimensions or we can simply compare to our previous 2D sketch relate to by equal radius. Now select both the 2D sketch now. In the graphic window, I am going to select both the sketch. Holding your control button, we get the equal constraints selected. Once it is equally constrained, then coincided with the vertical center line. Now, the another 2D sketch is also drawn. Then converted into a 3D curve. How we can easily convert it into a 3D curve? Just to select the sketch as well as go to the R profile, projected curve, sketch on sketch type, choose the direction, whatever the respective direction we need to create a 3D curve at the right area. Once it is properly created, the 3D curve is now created. From the end point, I am going to create a new 2D sketch profile at the top end and bottom end position. Use a 3-point arc. Just to select a start point, end point and midpoint. Afterwards, pick this particular point as well as a curve and make it into a pierce connections. Then select both the curve to make a tangential connections also. Once the endpoint gets fixed, now use the smart dimensions, then give the dimensional value of 25 radius. Afterwards, selecting this particular point as well as the center point to make an horizontal connections. Then exit the sketch now. Then choose the right plane, create a new sketch. Afterwards, use the 3-point arc again from the bottom end just to draw another profile. So select a point first, hold your control button, choose this 3D curve and make it into a PS connections. Afterwards, use the tangential connections also. Once it is properly created, now based on the previous sketch, I am going to transfer this with an equal constraints. Select the center point to make a horizontal connections. Then exit the sketch. The current 2D sketch is also created on the two opposite portions. Now I am going to prefer a 3D sketch because look at it, it is not properly connected into a single curve. Choose this 3D curve, helix curve as well as a 2D sketch and use the convert entities to project it on a 3D sketch area. Afterwards, we just going to hide the previous sketch as well as choose this particular point, drag it up to its point itself. It is automatically gets coincided with each other. Look at the positions, it is coincided now. Same as like selecting this point again, drag it and specified on this particular location. It is automatically coincide and make a tangential connections based on this curve as well as the 2D sketch. Then hide the helix curve, overall helix curve. Look at it. Here we have the complete 3D sketch into a single sketches itself. Before using a swept boss, now we need to draw a simple circular profile at the particular end. So choose the top line and select this bottom end point. Create a new profile at this area. Once the new plane is created, select it and create a sketch. Afterwards, draw one simple circular profile and locate it on these locations. It is coincided on this exact area. Only thing we need to done from here means selecting the center point as well as an origin to give the vertical constraints. Then choose the smart dimensions. Then give the dimensions of 10 mm. Now exit the sketch. Afterwards, using this sketch profile as well as a path curve, we can easily make a swept body. So choose a swept boss. Selecting the sketch profile. In the path curve, I am going to prefer this 3D sketch to create a tension spring simply. Look at it, how easily we just created by using of a 3D curve as well as a 3D sketch. Based on a simple 3D curve, we can easily make a complete solid body within this swept bosses itself. If you just section the bodies also, we can easily know what is the exact details we just done from here. Thank you. More on www.kalire.in.